Neurons are specialized cells that generate electrical impulses called action potentials. They begin at the body of the neuron and self-propagate down the branch called an axon. Action potentials are fluctuations in the voltage across the neural membrane that result from the distribution of charged ions across the membrane. The neural membrane has special embedded proteins called channel proteins that allow sodium and potassium to pass through when the voltage fluctuates. Sodium ions flow into a patch of axon from the adjacent extracellular space, causing that patch to depolarize. This triggers the opening of sodium channel proteins in the next section of the axon, sending the voltage fluctuation down the line. The voltage across the neural membrane is about -70 millivolts. The inside of the membrane is negatively charged due to a large concentration of negatively charged ions. The voltage changes to about -65 millivolts, causing the nearby sodium channel proteins to open. Sodium ions flow from high concentration outside to low concentration inside. The sodium channel proteins then close and are temporarily unable to be activated. The adjacent patch of axon becomes less negative on the inside relative to the outside, rising to +40 millivolts. When this happens, the potassium channel proteins open and potassium ions leave the cell. The voltage changes across the membrane, dropping from +40 millivolts to -90 millivolts. As the impulse reaches the axon terminal, neurotransmitters are released which influence the neighboring neurons.